Hello everyone, Swagatam and very warm welcome to all of you at this amazing platform of PW Gulf. My name is Aman, your favorite maths buddy. By now you have already known this part, right? Now, today we are going to revise the chapter of areas related to circle. Many of you will be doubting, so why areas related to circle first, why not circle? There is no difference as such, both the chapters are not interlinked at all. So when I start this chapter, I'll be talking about circle basics at the very starting, but as such there will be no direct connection. So nothing to bother about. Don't think that I don't know circle. How will I calculate the area related to circle? This will be totally dependent on the previous knowledge you have related to the area related to circle. And that is the circumference, the perimeter. I hope you understand the difference between perimeter and circumference. If you say yes, that means you don't have a clear understanding because they both are same. And most importantly, the area of the circle, which is pi r square, and that is the only thing which is required at the starting of this particular chapter. Other than that, nothing is required at all. So on that note, we can start. But first of all, another question which can come to my mind, sir, for other figures we generally look into the chapter where we deal with area, surface area, volume, all these things, right? In this case of circle, why a special case, why a separate chapter? So the thing is again very obvious. Now circle is a figure which is different from rest of the figures, like the triangle, the square, rectangle. Over there, all these figures are made up of straight lines. But this figure is not made up of straight line. This figure is made up of a round thing. I don't know what that round thing is. Basically, it's represented in a round manner. It doesn't have any edges. It doesn't have any corner, right? That is the point and that makes this figure special. I'll talk about the basic of this figure as I mentioned. Let us first start over here and understand what are we going to cover at the very starting. So over here, we are going to talk about three particular things in this particular chapter. The first thing will be sector. I'll be talking about what exactly is a sector. We have to calculate the area of the sector, right? Then we are going to move forward the length of the arc. Now what is arc? I hope you all had compass. At least that is the thing which you would be having. During my time we used to carry a geometry box of camel, and especially when there was a chapter of construction coming up, the teacher would have instructed that you have to carry the geometry box, and in the geometry box there would be a compass. So compass, what do you do with the compass? You make arc like this. Arc like this. So if you have no clue what arc is, then you are not at the right spot at this point of time. Going forward, once you have covered this part of sector and length of the arc, then the final nail in the coffin, and that will be the area of the segment. We'll talk about what exactly is segment and how to calculate the area of the segment, and this will go in this flow as it. In this manner, we'll be covering it up. So first thing first, what exactly is a circle? What are we going to talk about? So circle is a plane figure. I hope you have a clarity of plane figure. In the previous of 5 sessions, I have discussed about this, that there is a difference between a 2D figure and a 3D figure. Right now, I'm having a pen. This seems to be a cylindrical shape, right? I hope you have understanding of cylindrical shape. If you don't, then nothing to worry about. Look for the cylinder at your home. That is a 3D shape. But when you draw a circle, over here like this. Now this is a 2D figure. Why 2D figure? Because it is being represented over here just like this, in one single plane. On the other hand, if I talk about a cricket ball or a golf ball or a hockey ball, whichever is your favorite game, may it be football. So let's talk about football. So football is a 3D sphere, 3D thing, over which we have to do the representation on the paper. It will be not exactly right. So for example, if I have a dice, so dice is basically a cube. So for that, what I do, not only square, I have to do the extension of the square in this manner. I have to show that there is a front side, there is a back side, there is another side, left, right, all these side views. So this is the difference between a 3D and a 2D figure. Ultimately, if you come to the name itself, nomenclature, a 2D, 2-dimensional and a 3-dimensional figure. So all these figures, square, triangle, rectangle, including the circle, are 2D figures. So this is a plane figure. Second, I have already explained no edges, no sides as such, no edges, no corner, no sides as such. This is a round figure. And a special thing about this round figure is that all the points of a circle are equidistant from the point at the center. They are equidistant from a point at the center, and this is center over here. So if you observe from this point to this point over here, whatever be the distance, that distance will be same from this point to this point, or from this point to this point, or from this point to this point, Any point if you check for, all the distances would be same. Now you can tell me the name of that distance which you are quoting over here. The name of the distance is radius. We call it as radius. This is called as radius. Radius, represented by simply r, represented by simply r. There is a big brother of radius. You must be knowing big brother of radius, which is called as diameter. Diameter. And diameter is basically what? Represented by d, which is equals to 2 times of r, which is equals to 2 times of r. So very simple thing, if I talk about a circle, and a point, from one point to other point, if I connect a line, and that passes through the center, if any line has been drawn connecting two points, connecting two different points on the circle, but the line is passing through the center, that gives us an assurance that yes sir, this is a diameter of the circle. And if it is a diameter, I want to calculate the radius, I have to just do the half of it. So if 10 is the diameter, 5 will be the radius. If 50 is the diameter, 25 will be the radius. And if 10 is the radius, then 20 will be the diameter. That is all the very basic thing about circle. Other than that, sir, what is required? Other than that, the requirement is of circumference. Circumference is what? 2 pi r. What exactly is circumference? Now, we generally talk about a term called as perimeter. Over here, we call perimeter as circumference. It is called as circumference. Circumference or the perimeter is the boundary length. So over here, let's assume that this is simply a bangle, So I hope you would have seen bangle ladies do wear the bangles. Now, how much length is there? If you put up a thread across it, you will get a clarity how much length is that. And that length can be called as circumference, or in general we call it as perimeter. The formula for that is 2 pi r. What is pi? We'll have some other session talking in detail about the pi. If you want, you can look about what exactly is pi, but it's a very interesting thing. It's a very interesting thing in mathematics, and still we do a lot of research in mathematics. So these days also, the PhD candidates who do a lot of research, they have the topic related to pi. So you can on your own do some kind of a research and understand about pi. So the formula is 2 pi r. Pi generally have the value of, the approximate value which we take is 22/7. And if specifically mentioned in the problem over here, so the problem in that case it will be 3.14 if specially mentioned over there. Again, a very basic thing. Next thing, and I would say the last thing that I will talk about over here in the very basic of circle is the area, that is pi r square. Pi into radius. The radius has to be multiplied 2 times over here. That will be area. And that is all we have as the very basic of circle. In grade 6th, 7th, I believe by the grade 7th, all of this have been already taught. They already teach all these things. So when you are in grade 10th, there is nothing as such in this particular chapter that you would not be knowing at the moment. So these are the basic. If you know this much of basic, you can enter into this chapter and start learning. So once this basic is covered, now we enter into the part, as I told, the first thing, area of the sector. To understand area of the sector, it is important to understand what exactly is a sector, right? What exactly is a sector? Now, to understand sector, there are multiple ways. The best way is, you would have seen pizza. Many of you would be liking pizza, have a liking for pizza. Whoever likes the Western food, or I would say appropriately Italian food, they would be liking pizza quite a lot. From the top, if you see, it's like a circle. So when we talk about the slice of it, so when you go any pizza store, they cut into multiple parts. And in this manner they generally cut. So when you are taking the first bite, you will be taking the first slice of pizza like this. This will be the slice of it. In this manner, we'll be having a slice of pizza. And exactly this thing is sector. This exactly is a sector. It is some portion of that circle. So how would I define exactly a sector? Sector is basically the area surrounded by the two radii. What is a radii? Radii is nothing but the plural of radius. So two radii and an arc. Arc I have already told. Now what will be an arc over here? This will be the arc over here. This is the arc which we are mentioning too. This is the arc, and these are the two radii. Within these boundary, how much area is there? That will be called as the sector, area of the sector. Area of the sector. So this triangular looking like figure, not exactly triangle. Why not exactly triangle? Because you can see there is not a straight line at the bottom. At the bottom, it's not a straight line. It's a curved thing. So it looks something like this. It looks something like this. Alright, so this is the slice of bread, slice of pizza, whatever you want to say. So this exactly is a sector for a circle, and the area of it is what we are interested in, or I must say the portion of the circle. Other examples of sector as per se, sir. So you must have seen the dartboard. I don't know how many of you know about the dartboard. There is a circular board which we put on the wall, and then we have to put the dart on it. So it has multiple portions like this, and over there also we have segmentation like this. Over there we also have the segmentation like this. So again we are talking about what? Again we are talking about a sector over here. So basically wherever we are talking about some portion of the circle, and all the three lines are not straight line. Two lines over here joining the radius, and the third line basically is the joining these two radii will be the sector. Another case which I can quote to you very simply is the pie chart. If you have seen pie chart, it's a representation like this. Let's say 20% this much, 30% this much, for 60% this much, like this, and so on. It's not exactly 60%. Don't take it deliberately that this is 60%. No, this is not 60%. It's just a representation for your understanding over here. Now this again is basically what? This is again a sector. So these all are examples of sector, and you would have come across examples of sector very often. Now we are interested in the area part. Why? Because we want to eat a pizza, right? And I want to know how much pizza I would be getting. So to calculate the area of the sector, it's very simple to understand that it is some portion of the circle itself. So when I am talking about circle, so what exactly is the area of the circle? If this is a circle with the center, and this is having a radii, if it is having a radii r. So first of all, this is the radii, this is also radii. Both are radii. So the area of the circle will be what? It will be pi r square. Pi into radius. Very simple formula. Now I am saying this sector in particular is some part of the circle, some portion of the circle, some percentage of the circle, whatever you want to say. Now, how would I get to know how much portion of the circle it is? So for that, if you remember in the case of pie chart also, it exactly dependent on the central angle, how much central angle we have at the center. Between the two radii, how much angle is there? If the angle is very big, so that means more portion of the circle we are going to get. If the angle at the center is less, we are going to get less area, right? So it totally depends on this much. And if you remember pie charts, so what used to happen? How would we get to know? Theta upon 360 degree. This decides how much portion, how much part of the total. So let's say over here, if I say 180 degree, I hope you have understanding. 180 degree is a straight line. So if I make up a straight line, that means we are talking about diameter over here. We have reduced the circle into two semicircles. So 180 by 360 degree, we are talking about half of the circle. So if we have the theta value, the central angle, this is the theta over here. If we have this value, we know how much portion of the circle we are talking about, and we have to simply multiply by pi r square. This is what? This is the area of sector. Very simple. So what is the area of the sector? It is theta by 360 degree into the pi r square, the total area of the circle. This is very simple to understand. Theta by 360 degree over here is just telling you how much portion we are talking about, how much portion of the circle are we interested in. So once again, if I have to reiterate this part, this is a complete circle. For complete circle at the center, 360 degree angle is made, and that is why we have to do the comparison. We want the ratio by 360 degree. 360 degree in the denominator, in the numerator, the angle which would be made at the center of that sector. So total area is pi r square, and we need the area of the sector, so that will be theta by 360 degree into pi r square. And this is the formula which you need to remember. And to be very honest, if you have noted down, well and good. Even if you haven't noted down, no need to mug it up. If you understand what exactly is sector, then automatically remember that you have to multiply the area of the sector with the portion, how much portion we are talking about, and that is theta by 360 degree. And that is all we have in the sector. It's a very simple and a very crisp chapter. And initially what we do, learn the formula and then we proceed with the problem, practice problem. So see, over here we are talking about area of the sector of a circle with radius as 6 centimeter if angle of the sector is given as 60 degree. So if you have focus on the formula, there are two variables which we need to require, which are required for us to know. What are these two? First thing is radius, and second thing is the central angle, that is theta. If we have these two values, what two values, sir? If we have the radius value is given to me as 6 centimeter over here. Radius is 6 centimeter. So if we have the radius, that is 6 centimeter, and if we have the theta, the central angle over here given to me is 60 degree, then I can calculate the area of the sector. How? Area of the sector, very simple. Area of sector, the formula is theta by 360 degree, that means the portion of the circle we are interested in, multiplied by the total area, that is pi r square. Put all the values you have. Over here it's not mentioned what pi you have to take, what value of the pi you have to take. So obviously you have to take the value of pi as 22 by 7, that's it. So put up all the values over here, you will be having 60 by 360 degree multiplied by 22 by 7 multiplied by r, which is 6. So 6 into 6. So over here, this term will be cancelling out 360 degree. How many times? 6 times, and 6 will be cancelling. 6 over here. We are left with 22 into 6. That will be 6 into 2, 12. 6 into 2, 12 plus 1, 132 by 7. Is this the final answer? No, this is not the final answer. Never leave whenever you are calculating area, perimeter and any of the such kind of a thing, because you would be having some unit. So radius is in centimeter. So over here area would be in centimeter square. It will be in centimeter square. 132 by 7 centimeter square. And one important thing I want to tell you, over here I am here to tell you about the concept. I want to teach you the concept, but it's up to you. There are two things involved in any kind of a problem. What two things, sir? First is concept and second is calculation. I will be teaching you concept over here. Calculation is not my part. No one can teach calculation. I cannot teach calculation. You have already learned calculation when you were in your elementary grade. What elementary grades, sir? First, second, third, fourth, fifth. Over there you learned about how to do addition, subtraction, multiplication and division. Now no one will be teaching you the elementary grade mathematics, that is calculation. So that you have to practice on your own and make sure that you are confident on that part. The point I was making over here, that don't leave in the fraction. If possible, try to give the answer in decimal. Try to give the answer in decimal. That will be better. Over in the case of objective examination, it's good that you have the option in whatever form it is, accordingly you have to answer. In the case of subjective examination, it depends. You can leave it like this, but I would suggest, if possible, if it's a small thing, then answer in the decimal form. So again, you have the liberty, but I would advise in that favor. So this is how you calculate the angle of the sector. Another example we can look forward to. Area of the quadrant of a circle whose circumference is 22 centimeter. Now, interestingly, we don't have the radius. Interestingly, we don't have the central angle, that is theta. Now, these two things are missing. But if you read the question carefully, you will get to know both the value. Why? Because two information are given. Additional information. What additional information? First additional information is quadrant. Now, if you have no clue about quadrant, that means you haven't been revising the sessions. Well, I had taught you already the coordinate geometry. In the case of coordinate geometry, what we had quadrants, right? We were having 4 quadrants: first quadrant, second quadrant, third quadrant and the fourth quadrant. What was that exactly quadrant, sir? Why quadrant? Because the entire plane was divided into 4 parts. And how? Each part was made up of this 90-degree angle. Quadrant is nothing, 1/4. Quadrant is nothing, 1/4. How 1/4? You can easily observe 90 degree by 360 degree. This is what? This is equal to 1/4, and quadrant is exactly 1/4. Quadrant is exactly 1/4. So from this, what do I get to know? From this, I get to know the value of theta. Theta is 90 degree, or directly I can put up the value as 1/4. Why to put 90 by 360 degree? And secondly, circumference is mentioned. Circumference. It means I can do the calculation for radius. See, very simple. Circumference is 2 pi r. And it is being mentioned to me as 22. So I know rest of the values, 22 by 7 upon 7 into radius. So here 22 cancels out 22. Radius is left with 7 by 2 what? Centimeter over here. Centimeter. So circumference should be centimeter square. No, say circumference is the length. Length is always in centimeter, meter, kilometer. It is the area which is in meter square, centimeter square or kilometer square. You have the radius now, you have the theta part, area of the quadrant, or I would say over here the area of the quadrant or the sector, whatever you want to call. Let me call it sector so you don't have the confusion. What it will be? This time I'll be writing 1 by 4 into pi r square. Why? So as to give it a new touch. Where we are having 90 by 360 degree, which is reduced to 1 by 4. Always the quadrant will be 1/4 of the entire area of the circle. So putting up the value 1 by 4 into pi, that is 22 by 7. Radius value we have already calculated, that is 7 by 2 into 7 by 2. So do the calculation over here. This 7 will be cancelled out with this 7, 2 will be cancelled out with 11 over here. Can we cancel anything further? We are left with in numerator 7 into 11, that is 77. And in denominator 2 into 4, that is 8. How much? Centimeter square. Centimeter square. And that is our area of the quadrant. That is how it needs to be done. Moving on to the next question, I hope you have the clarity. No difficulty at this point for this problem. As I mentioned, radius and theta are the two things required for area of the sector, and they can be calculated by the information given in the question. The next question is not about calculating the radius, but yes, it's about calculating the central angle. Over here, it's talking about the length of the minute hand. They are talking about the time over here. Minute hand of a clock is 14 centimeter. So I hope you would have seen a clock. Definitely you would have. If you haven't seen a clock, what you have seen in the world. So we are having a minute clock. We are having basically minute clock and a time and hour clock like this, right? Now in this case they are saying that the minute hand is of how much length? 14. So this length is given to me as 14. This lengthy one is the minute hand. Find the area swept by the minute hand in 5 minutes. So let's say initially it was over here, and later point of time it reached something over here, or let me draw it with a different color so that you have a better clarity. Over here it is now at the moment, at this point of time, after 5 minutes, something like this. So what will happen now? If you observe from here to here, it has swept some area, and it is an arc of circle, and this is the arc of the circle whose area we are interested in. So what we need to do? Basic two things. Radius, I believe in the length of the minute hand is given. I hope we have the realization that the minute hand will be sweeping the area, and that is the basically radius of that particular thing. What about the central angle, sir? How much angle would be formed over here? This is the important thing missing over here. Can you think about it? Something else is given. They're asking about 5 minutes. 5 minutes. You know that how many minutes are there when that complete minute clock come back to the same position, So if you have that much of clarity that let's say the minute hand at the very starting was somewhere over here. It started from here and reached back to this particular position. So how much angle has it covered? How much angle it is covered? 360 degree. I hope you have the clarity. This complete angle is 360 degree. And how much time has he covered? In how he or she, I don't know. In how much time it has covered? No, he and she. How much time it has covered this angle? So it's a 1 hour time. When minute hand complete one revolution, that means 1 hour. And 1 hour is basically 60 minutes. In 60 minutes, we are having 360 degree. So in 1 minute, how much we will be having? 360 degree by 60, not 60, sorry, yeah, 60. This is for 1 minute. What we are interested in? We are interested in 5 minutes. So let's talk about 5 minutes. For case of 5 minutes, 360 degree by 60 into 5. So from here, 0 cancel out 0, 6 cancel out, 36, 6 times 6 into 5, that is 30 degree. In 5 minutes, it will be making a central angle of 30 degree. You have the central angle, you have the radius over here. So the area of the sector would be very simple to calculate. Area swept over here. Let me talk about the area swept. Enough of the area of the sector. Area swept will be what? Theta, that is 30 by 360 degree multiplied by pi, that is 22 by 7, r, that is 14 given to us, 14 into 14. If you do the calculation, you will get the area swept by the minute hand, and this is how we need to approach the problem. So over here, what I taught you are the types of problem we can have. One can be a very simple problem where just apply the formula, that's it. Another problem can be where you have to just calculate the two requirements, basic two requirements, theta and radius. Indirectly they have given. And the third case also the same to second case, but this time you have to apply your understanding of the things around you. That is what real life application is all about. So I hope we have the clarity about these three problems. Moving ahead to the next thing, which is called as length of the sector. Now, as the word suggests, we are talking about the length of the sector. Are we interested in the length when we talk about the complete length? See, we are having a circle like this. We are having the circle like this. So I told you, sector is made by the two radii. This is the center. So two radii over here, and the arc. This arc over here. This arc over here. And we are interested in the arc, not the sector length. I would say this is a misinterpretation over here. It should have been arc. Length of the arc. I would call it to be length of arc, not length of the sector. That I would not call. I would call it length of the arc. Now, which arc I am talking about? I am talking about this particular arc, which is making up the sector for me. Which is making up the sector for me. And after seeing this length, one thing should come to your mind. What? So, when we talk about the area of the sector, we were talking about the area of the complete circle. And we are talking about the length of this arc. We should talk about the length of the complete boundary of the circle, which is circumference. So, the complete circumference, which we know, is 2 pi r. And when we have the central angle through which we calculated the area of the sector, through which we also can calculate the length of the arc. Why? Because theta is telling you what? How much portion of the circle we are talking about. So if total this much is the boundary, so the length of the arc will be what? It will be some portion, theta by 360 degree. Some portion of the entire length, that is 2 pi r. So, if you have theta, if you have radius, you can always calculate the length of the arc which make up the sector, and that is the point over here. No much change from the sector case. The only difference comes in this case is, in that case we are talking about area, over here we are talking about the length, or I must say the circumference. So the length of the arc formula is very simple. Circumference of the circle multiplied by theta into 360 degree, which is some portion, some fraction of the entire circle we are talking about. So again, the next thing, as I mentioned, you can note it down, but you have to understand what we are talking about over here. So going ahead, there are questions which ask about the length of the arc. See, area of the sector of a circle of radius 36. Radius mentioned 36 centimeter. Then they are saying the area of the sector is 54 pi centimeter square. That is an area. So if you have any difficulty understanding whether this is the length or area, you can always check for the units over there. This is centimeter, this is the centimeter square, so this is the area part. Find the length of the corresponding arc of the sector. So arc of the sector they are interested in. So for the arc, what are we interested in? We are interested in theta. I want theta value, I want radius value. And this is the second case of sector, second category of questions we calculated in the case of sector. Theta and radius have to be calculated from the given information, and it's a very simple thing. They have talked about already the radius, it's given to me. Why have put up a question mark? I should not. This is given to me as 36 centimeter. Only theta is missing, and area of the sector is given to me. Who would count about that? So area of sector is theta by 360 degree multiplied by pi r square. Now this part, area of the sector is given to me as 54 pi. Let's put up the value 54 pi and equate it to theta by 360 degree. There will be only one unknown left over here. There will be only one unknown left in this equation, and which you can always do the calculation for, and that is theta. See, pi will be cancelling out pi. See, 36 will be cancelling this 360 degree how many times? 10 times, right? So ahead of it, this will be 3 times 18, 3 times and 18, 2 times over here. 2 cancelling out 10, how many times? 5 times. So 5 into 3, that is theta is coming out to be 15 degree. When you have theta value, when you have radius value, is it any difficult part to do the calculation for the length? No sir, length is very simple. Length formula, as we know, is theta by 360 degree into 2 pi r. But I'll ask you to be more cautious over here, because since sector is asked more, many people when asked about the length of the sector, they again put up the formula pi r square rather than 2 pi r. So this is a mistake which you need to avoid. Put up the value simply. We'll be having 15 by 360 degree multiplied by 2 into pi, that is 22 by 7, into r, which have been given to as 36. So into 36, not 36 into 36. That's not required from your end. So 2 pi r is what you have to be cautious when we are dealing with the length of the sector over here. So this is another type of question which can be asked, and the one simple case would always be when theta and radius is given, you have to just put the values and calculate. See how simple this particular chapter is. There is no complication as such. There is no complication as such. The final complication will come in the final segment of this chapter. Final segment? Yes, in the final part we are talking about segment, right? So I'll come to that. First again, let me show in a very straightforward way what a simple question in this particular thing. In a circle of radius, radius is given to you is 21 centimeter. Theta is given to you, subtend an angle at the center in this manner. Theta is given to you as 60 degree. What do you have calculated? Length of the arc. So length of the arc is very simple. Length of the arc would be what? Theta, that is 60 by 360 degree multiplied by 2 into 22 by 7, the value of pi, and multiplied by r, that is 21. Simple. By 21, this cancels out this 3 times. This cancels out this how many times? 6 times. So again 3 cancelling out 6 2 times. 2 cancelling out 2 over here. What is left? 22. So 22 centimeter is the length of the arc. See, in a single step, this might be a 1 marks question and can be asked as a MCQ, the length as well as area. And other question can be asked for 2 and 3. Not multiple question can be made from this particular chapter which are of 5 marks or more. That would not be the case mainly. So one part of it asking about the length, the other part of it would be asking about the area of the sector, which again is very simple. Area being theta, that is 60 by 360 degree multiplied by pi r square. Don't multiply 2 into r this time, that would be a basic error, into r, that is 21 into 21. Again the same kind of calculation, into 3. Over here this goes 6 times and 3 cancel out this 2 times. So this will be 11. 11 into 21, 11 into 1 is 11, 11 to 22, 22 plus 1, 231 centimeters square. Very simple, very simple. So this is what we have learned today. And things are very simple. A single formula, a 2 basic requirement, theta and radius. But that's not all in this particular chapter. There is one final thing, which is to find the area of the segment formed by the corresponding chord. Segment. What is that segment? I call the final segment of the chapter. So segment is some part of the circle again. So how it is different from the segment? How it is different from the sector of a circle? Understand. First of all, in a circle, we were talking about the sector. Now, if we talk about segment, so if you observe, in the case of sector, this was the radii, 2 radii, and this complete was the sector. But what happens if I connect this particular thing over here, 2 radii endpoints like this, and make up a straight line, connecting the 2 endpoints of the 2 radii which are making up the sector. And now we are having a triangle over here. I'm not interested in the triangle, but yeah, the triangle will play an important role. The segment over here is this. This is the segment for me. So basically segment is the arc and this line which is joining the 2 radii end, 2 radius end which is joining these two. So this is the segment over here. And segment, as it's visible, how would we calculate the area of the segment? Understanding segment is very simple. How will we calculate the area of the segment? I'll come to the part of area of the segment. One more thing I'd like to mention which I hadn't talked about in the case of sector. Now see, this is the smaller portion of the circle, this is a smaller portion of the circle, there is a greater portion of the circle. Now this line over here is dividing circle into two different parts. One is the smaller part, another is the entire bigger part of the circle. So this bigger part will be the major segment. Major. What is major and minor? I hope everyone knows about the English, basic English. So this is the major segment and that was the minor segment. That was the minor. So this is minor segment. This is minor segment. And same term come for sector. Major and minor sector. Minor sector. Two terms appear. Major sector and minor sector. So be cautious about that also. Someone might ask, what is the major sector? So for the case of major sector, you have to just reduce the area of minor sector from the entire area of the circle, and you're left with only that area which is the major sector. That is how things work, and that same thing work for the segment as well. So if you have the area of the minor segment, then you can calculate the area of the circle, subtract the minor area of the minor segment area, you will be getting the entire rest of the area. These things are not that complicated. This is combination of figures. So what you have to find the area of the shaded portion. For that, what you do? You have to calculate the entire area, the rest of the area, subtract it, find the shaded portion. But now coming back to the part of area of the segment, that is the most important part for us, talking about the area of the segment. Now, area of the segment, how can I do the calculation? For this, do we have a direct formula, sir? No, we do not have a direct formula. No, we do not have the direct formula. But what can be done? It is like the combination of figure. We have already done the area of the sector. We have already done the area of the sector. So if I talk about the sector, this was the complete sector. The yellow shaded line is the sector. So if I calculate the area of the sector, and from the area of the sector, I subtract the area of the triangle, this triangle. If I subtract the area of the triangle, what will happen? If I subtract the area of the triangle, if it's not visible, so let me draw another line over here. This white one is the triangle I am talking about. So if I subtract the area of triangle, what I'll be getting from this? From this I'll be getting area of segment. Area of segment. So area of segment is equal to what? Area of segment is basically equal to the area of sector minus the area of the triangle. This is the basic formula, and I don't think this is the formula at all. This is a simple statement. You have to calculate the area of the sector, subtract the area of the triangle from it, and you will get the area of the segment from that part. But the problem arises, sir, how to calculate the area of the triangle? Now, calculating the area of the triangle can depend how much knowledge you have, how much previous knowledge you have. For that, understand one thing. Triangle can be of different form, but one important thing is, in the case of triangle, area of triangle is what? Area of triangle will always be half into base into height. And what is this base into height? Two perpendicular lines, one being the base, another being the perpendicular. Both should be having 90-degree angle. That is the requirement. That is the most important thing to be there to calculate the area. Now, if you have enough of the theory, so nothing, segment is also very simple to be calculated. We have to calculate the area of the sector, subtract the area of the triangle, we know the formula as well, and then we'll do it. So, in the previous question, if I go back to the previous question over here, where they had already asked you the area of the segment, formed by the corresponding chord. Chord is clear now, that line joining the end point of the two radii. Now, understand, we are having a circle. This was the sector for which we have calculated the area, and we are interested in this segment. For this, what I told, area of the sector we have already calculated. This is already done. What I want, I am interested at the moment in area of triangle. How would I calculate the area of the triangle? Now see, area of the triangle would not always go in the same manner. You have to read the question carefully, check what is the central angle. This case, the central angle is 60 degree. So if I talk about it, this is the central angle which is 60 degree. If I talk about this line over here, what are they? They are radius. So R and R, and when the two sides of the triangle are equal, what do we call it? We call it isosceles triangle. And for the case of isosceles triangle, along with the two sides, the opposite two angles are also equal. So this angle and this angle would be equal. Now something should be coming to your mind. If this angle and this angle should be equal, in that case all the three angles would be 60 degree. All the three angles would be 60 degree. And if we know that all the angles are 60 degree, what does that mean? This is an equilateral triangle. This is an equilateral triangle. And for equilateral triangle, area of equilateral triangle is what? It's root 3 by 4 into side square. Let me write side itself. It's side square. This is the formula. You apply this formula. You know the side. Don't get confused, sir. What is the side? I don't know the side. You know the side. The side is radius. This is R. This is R. This will also be R. This will also be radius. Why? Because this is equilateral triangle. And since you know the side length, you can calculate the area of the triangle. If you have the area of the triangle, you have to subtract both of them and you'll get the area of the segment. Problem done. As I told, I am over here to teach you concept. The calculation part is your own. So this was one case of segment where the central angle is 60 degree. I told you that it totally depends on triangle, and in the case of triangle, things can vary. Like what? Now, I have told you about 60 degree. Now, there might be other cases as well. An important case over here, which is having a central angle of 120 degree. What happens in this case? Again, 120 degree given, radius given to you. So area of the sector is very simple. This can be done. What about the area of triangle? So for the area of triangle, look into the figure first carefully. Here we have the circle. This is the sector. And this will be our segment. This is our segment in which we are interested in. Right? This is the segment we are interested in. Now, for this we need the area of a triangle. The central angle given to me over here is 120 degree. Now, for 120 degree, first of all, it's not 90 degree, it's not 60 degree, that I cannot calculate for the equilateral triangle. 90 degree not given. For 90 degree, the easier thing would have been half into base into height. That's not going to happen. Central angle is 120 degree. So what can be done in this case? Now for the case of 90 degree also understand one thing. In this particular case, if let's say the area of the triangle I am talking about. Now this particular angle over here, if this particular angle over here becomes 90 degree, if this angle becomes 90 degree, this angles become 90 degrees. So then how would we calculate the area of the triangle? In that case, what happens? Is area of triangle will be very simple to calculate. I told you half into base into height. This is R, this is R, this is my base, this is my perpendicular height. That means the base and height both are equal. The area of the triangle will be half into R into R. This will happen when theta is equals to 90 degree. When theta is equals to 90 degree, this would be the case. When theta is 60 degree, I told you area of equilateral triangle, the previous case, the area of equilateral triangle. For 90 degree, this will be the case. And now we are into the point where we are having 120 degree, the third case. So that is what I am telling. Segment is an interesting thing. Segment over here asks you to think about how to do the calculation for area of the triangle. In the chapter of area related to circle, the most crucial part is to calculate the area of triangle. Let's come back to this problem, 120 degree. What's the way forward, sir? Now tell me the way forward. Listen very carefully. There is a property of circle, which you would have learned in grade 9th. When you draw perpendicular, from the center on the chord, Perpendicular on the chord. That means the angle made over here is 90 degree. This angle is 90 degree. So what happens with the chord is, the chord is divided into two equal parts. If I say this is B, this would also be B. This length over here, this is B, this length would also be B. Two equal parts. So the entire length is what? B plus B, 2B. Entire length is B plus B, 2B. So this entire length, if I say this is A, this is B, and this point is O. So, and let me call this point as, let me give it a name as C. So ACB, this is a straight line. So AB is what? AB is B plus B, that means 2B. 2B. Now, I want 2B, that means basically B, if I have the value of B, so I'll get AB, and I want OC. I want OC. Let me call OC as the P, perpendicular. OC for me is P. If I get these two values, I'll get the value of the area of the triangle. So, I have drawn a perpendicular on the chord at the angle of 90 degree basically, and yeah, dividing into the chord into equal parts. Focus into the two triangles, triangle AOC and triangle BOC. In triangle AOC and BOC. AOC and triangle BOC. What is happening? We are having a 90 degree angle over here. We are having a 90 degree angle over here, right? We are having a 90 degree angle over here. So 90 degree angle, basically what does that mean? 90 degree angle at C. So C equals to C. In this case over here, in this case over here. 90 degree each. This is 90 degree angle. This is the hypotenuse. And both the hypotenuse is what? Both the hypotenuse are the radius. So OC, sorry not OC, OA is equals to OB, which is equals to R over here, which this was equal to 90 degree. And this length equals to B, this length equals to B. So AC is equals to BC, which is both equals to B. This is 90 degree, this is hypotenuse, this is side. If you know, triangle AOC would be congruent to triangle BOC. And by what? By RHS, sir. By RHS. But what's the point of doing all this, sir? You don't have to show entire thing, but you have to understand each and everything. Since these two triangles are congruent, so whatever angle this would be, the same this angle would be. And what will be this angle over here? This will be basically 60 degree now. Two equal parts, 120 degrees divided into two equal parts. If I call this basic part as X, understand this, X plus X equals to 120 degree. That means 2X equals to 120 degree. That means X value is what? 60 degree. 60 degree. So X value is 60 degree. Over here in this triangle we are having 60 degree. If this angle is 60 degree, what will be this angle? I believe 30 degree, right sir? 30 degree. Now I know 60 degree, 30 degree, 90 degree. Basically it's a right angle triangle. Basically it's a right angle triangle. Let's talk about this right angle triangle. Let's talk about this right angle triangle. So in right angle triangle, this AOC, if I talk about sine of 30 degree, what will be sine of 30 degree? Perpendicular by hypotenuse. Perpendicular by hypotenuse. Hypotenuse is R. I don't know the value of P, but I know the value of R. R value is given to me 12. R value is given to me as 12. Simple. Sine 30 degree also I know that is 1 by 2 equals to P by 12. That means P from here is what? 12 by 2. That means 6. One of the value I have. P is equals to 6. For the area of the triangle, this value I have. Now coming back again into this particular triangle, trigonometry. I know that perpendicular by base is 10. So 10 of 30 degree will be what? 10 of 30 degree will be perpendicular by base, P by B. I know the value 10 30 degree is 1 upon root 3. I know the value of P. I have already calculated 6 by B. From here, what is the value of B? If you do the calculation, 6 into root 3. 6 root 3. If B is 6 root 3, what will be AB? 6 into 2, 12. 12 root 3. You have AB now, you have OC now, and you have the area of the triangle. Half into AB into OC. And that is what was needed over here. Repeating each and everything once again, you might have taken a lot. At the moment, you might be feeling overwhelmed by the information provided over here. See, when the case is of 120 degrees, central angle is 120 degree, the thing of equilateral triangle will not work, the thing of right angle triangle will not work for you. Now, you have to create a case where we can calculate the base as well as the height, perpendicular height. So this will be acting as a base, this will be acting as a perpendicular height. So first the construction was done from O to C, which is a perpendicular on the chord AB. So dividing AB into two equal parts, this was B, this was B, right? Now, since these two triangles will be congruent, so these two angles would be equal. The two angles would be equal. The two angles would be equal, that means both will be 60-60. Only in that case it is possible. It cannot be possible. One is 50, another one is 70, right? That's not possible. 60-60. This is 60, 60 plus 90, 60 plus 90, 60 plus 90, 150. Remaining is 30. We are having a triangle. Apply trigonometry over here. Applying trigonometry, in this case over here, sine 30, P by R, perpendicular by hypotenuse, perpendicular by 6. So from here, sorry, not 6, 12. So from here, 12 by 2, that means 6, perpendicular 6. Similarly, perpendicular by base is 10. 10 is 1 upon root 3. So 6 upon the base I don't know. Base I don't know. So base equals to 6 root 3. And I know I want this complete base. So 6 into 2, that is 12 root 3. I can put up the values over here, calculate the area of the triangle, area of the sector already done. So rest of the calculation can be easily done. And yes, the area of segment can be calculated. This will be done from our end. And that is how the problem needs to be tackled down. That is how the problem needs to be tackled down. So this was the case. This was the case of area of the segment. This was the case of area of the segment. And that is all we have in this chapter. That is all we have in this chapter. Understand one thing over here. The most important thing in this particular case was the area of the segment, and that involved triangle. Over there, in the case of area related to circle, you are worried that I don't know about circle, I haven't learned the chapter circle. But it's not the circle that is important at the moment. It's the important thing what you have learned before. That means the understanding of the triangle itself, understanding of trigonometry, and the basic properties of circle also. That will also be required. So this is the entire thing. The point over here is holistic knowledge is important to answer the problems, the good problems generally. So always remember whatever you are learning, not for the exam sake, for your own understanding, for your betterment. Alright, so practice will make perfect over here. As I mentioned, two things were involved. Concept and calculation. I haven't touched calculation. It's your segment which you have to deal with, and yes, you have to practice more and more problems related to segment. So that is all we have in today's session. I hope you have liked it, enjoyed it. In the next session, we'll be coming up with the next chapter. It might be circle, who knows. So meet in the next session. Till then, have a great time. Enjoy yourself. Bye bye.